Newton's three laws of motion. Within this section, I will present Newton's three laws of motion. Newton's first law relates to inertia. Inertia refers to the object's resistance to change. For example, a ping pong ball has much less resistance to move than a bowling ball. Therefore, the ping pong ball will have a reduced inertia as it is easier to move, and less force has to be applied to move it. Inertia is present both when stopping an object and starting the motion of an object. As a ping pong ball is easier to stop rolling and to start rolling than a bowling ball, which will have a far greater inertial resistance to stopping and starting motion. Furthermore, the inertial value is directly linked to an object's mass, as an object with greater mass will have a greater inertia, as due to the increased mass, they will require larger amounts of force to stop and start motion. As a result, objects with smaller masses, which have lower inertial value, are easier to stop, as less force is required to stop and start them. Newton's first law is as follows. An object remains in the same state of motion unless a resultant force acts upon it, meaning that an object moving at a constant velocity forever unless a force is applied to it. For example, if you were to kick a ball, if Newton's first law did not apply, the ball would if Newton's first law did not apply, no forces would apply to the ball. Therefore, the ball's velocity would remain unchanged as factors such as drag do not apply, leading the ball to roll at a constant velocity forever. However, in actual fact, when the ball is kicked, it will begin to slow almost immediately, as forces of resistance such as air resistance, drag, and friction all act upon the ball, decreasing the ball's velocity and eventually leading the ball to stop, as the forces propelling the ball become overpowered by the forces resisting the ball. Moving forward to Newton's second law. Newton's second law states the direction of an object's acceleration is the same as the direction of the unbalanced force, showing that size and direction of the force applied to an object determines its acceleration. This can be evidenced as acceleration is determined force over mass equals acceleration. Acceleration can only occur when an unbalanced force is applied to an object. This is because when an object is stationary, all forces applying upon the object are equal, which stimulates no movement. However, when one of the forces overpowers its opposite force, movement is triggered. For example, for a car to move, its thrust must overcome the car's resistance. When the car's thrust becomes higher than the vehicle's resistance, moving forwards motion will be achieved. Furthermore, acceleration is highly dependent on the object's size. This is because if there are two objects of the same size, one with a weight of 2 kilograms and the other with a weight of 10 kilograms, if the same amount of force is applied to both the 10 kilogram and the 2 kilogram object, acceleration of the 2 kilogram object will be significantly further, as the smaller object with a lower weight requires less force to overcome its inertial resistance. Therefore, a higher proportion of the force is used to actually accelerate the object forward, whereas the heavier object will accelerate less as a higher proportion of the force is applied to overcome the inertial resistance. Furthermore, less force is used to actually accelerate a heavier object. Furthermore, due to the heavier object's weight moving the heavier object at the same distance as the smaller object will require more force, as due to the excess weight, the heavier ball will create more resistance and require more energy to move the same distance. Newton's third law of motion is in response to reactive forces, stating that every action has an opposite and equal reaction. For example, in response to basketball, when a player jumps, they exert a certain amount of force from their legs into the ground. The ground will exert that same amount of force in the opposite direction back up into the subject, propelling them the basketball player upwards. This is because when the basketball player exerts their force into the ground, because the ground is an extremely large, unmovable object, instead of the ground moving, the smaller, more movable object in the form of the basketball player moves instead. According to KhanAcademy.org, the reason that actions have an equal and opposite reaction is because forces always occur in pairs. One body cannot exert a force without an experience of force upon itself. So every opposite has an equal and opposite reaction. You cannot have forwards motion without backwards motion.